So here's the worksheet that I was referring to in the end of the 5.3 lesson. In this worksheet, we are going to derive an equation that's going to help us in the main assignment for the 5.3 section. All right, so this is a little sample that they give you. It says a sample quadrilateral n equals 4, where n is the number of sides. So I've got 4 sides in this quadrilateral. And it says draw a line that divides a quadrilateral into 2 triangles. So this is exactly what I was doing in that last example on the notes. So divide it into 2 triangles. Again, you're just connecting all 4 vertices, but you already have this line segment here that's already part of the polygon, so you don't have to redraw it. And then this one is already part of the polygon, so we're not going to have to redraw that. So we divide it into 2 triangles. Here's one, and here's the other. And again, each triangle has an interior angle sum of its own that equals 180 degrees. So here we have a 180, there we have a 180. So ultimately we have 2 180s, which gives us 360. Now here they're showing that they're adding them. You could just do 2 times 360 since we have 2 180s, and we'd still get out 2 times 180 is 360 degrees. So either way, we get that 360 for a 4-sided polygon. I alluded to this in the end of the notes as well, in that last example. If there are 4 sides, we can only make 2 triangles. So 2 triangles, that's 2 less than the number of sides. Let's see if that holds true for all of these. So we draw line segments connecting all the vertices. You pick out one vertice. You draw line segments to all of the other vertices. There and there, and again, this one and this one are already given to us as part of the polygon. So on this one, I can make 1, 2, 3 triangles. And again, we know each one of these triangles has its own interior angle sum of 180 degrees. So I do 3 times 180, which is 540 degrees. So for 5 sides, we get 540 degrees because I could make 3 triangles. And again, 3 triangles, well, that's 2 less than the number of sides. There's a 5 here, 2 less is 3. I can make 3 triangles. If it's 6 sides, so we have 1, 2, 3, 4, 5, 6 vertices, 6 sides, but I can only make 4 triangles. 1, 2, 3, and 4. So again, 2 less than the number of sides. That's how many triangles I can make. So on this one, I've got 4 triangles. Every triangle has an interior angle sum of 180 degrees. So I have 4 180s making up this polygon, which gives me 720 degrees. All right, keep on going. We've got 2 more on this side here. So if n is 7, I'm going to go ahead and connect all of my vertices together here. Again, I've already got this one connected by the polygon side. Connect these. I already know that I can only make 5 triangles. Again, I already mentioned that. So here I've got 1, 2, 3, 4, and 5. 5 different triangles. So I've got 5 times 180. So I end up with 5 times 180, which is 900 degrees. And on the last one, again, put all the vertices in, connect all the vertices with line segments. I've got 8 sides, so I know I'm going to be able to make 6 triangles. So connect all of these. 1, there's 2, 3, 4, 5, and then 6 right here. So 1, 2, 3, 4, 5, 6 triangles. Again, 2 less than the number of sides. So I've got 6 times 180. That's how many angle measure. That's the angle measure of all of these triangles, and I have 6 of them. So I multiply by 6, and I get 1080 degrees. All right. So we've got all these different angle measures, and on the back side of this worksheet, it says use the table to organize the results from activity 1. Well, this was activity 1, so you just look at your results. So 4 sides was 360 degrees. 5 sides right here was 540 degrees. 6 sides right there was 720 degrees. 7 sides was 900, and 8 sides was 1080. And of course, the interior angle sum of a triangle, so you have 3 sides, is 180 degrees. All right, so we organize our data into a table, and then it says plot the points. Well, our x-axis is going up by 1, so that's the number of sides. Our y-axis is going up by 180, so that's the interior angle sum, and they're using an S for the sum and N for the number of sides. So for 3 sides, so we go over 3, we go up to 180 and plot a point. 4 sides, we go up to 360, so 360 for 4 sides, plot a point. And 5 sides, 540, 6 sides, 720, 7 sides, 900, and 8 sides, 1080. So you might notice this is a linear pattern. So write a linear equation that relates s to n. Well, remember, every linear equation can be written in the form y equals mx plus b. But on this one, we don't have y and x. We're using s instead of a y, so we're going to have s equals m. Instead of an x, we're using n, so s equals m n plus b. But it's still the format y equals mx plus b. It's just y is now renamed s, and x is now renamed n. So we still need a slope for m, and the y-coordinate of the y-intercept for b. So what is the slope of this? Well, just look at your rise over your run. So my y's, or in this case s, is going up by 180. Well, my x's, or my n's, are going up by 1. So my slope is 180 over 1, or just 180. And you can get that from the graph as well. Rise over run. You're rising 180, running 1. Rise 180, run 1. So I'm going to plug in 180 for m. And then I have n plus b. Well, b again is the y-coordinate of the y-intercept. So I don't have a y-intercept on my graph yet, but if I were to go backwards, so I don't have a point here, I'll just put an open point. If I keep going with this pattern backwards, I get to negative 360. So I'm going to put, instead of plus here, I'm going to put minus 360. Minus 360. And there's your equation. S equals 180n minus 360. So it's 180 times the number of sides. So if, let's say you've got 4 sides, you plug in a 4 here. So you get 180 times 4. You're subtracting off 360. It's like you're subtracting off the interior angle sum of 2 triangles. Because you don't have the number of triangles for the number of sides, you've got 2 less. So you subtract off the interior angle sum of those 2 triangles. So this is your equation that you're going to be able to use from this point forward. S equals 180n minus 360. You just plug in the number of sides for n, and you can get the interior angle sum. You no longer have to break them down into individual triangles like this. Now, some of you might want to do that for a little while until you're used to calculating it with the equation, but try to also use the equation if you do it this way, where you break it down into triangles. Try to get used to using that equation, because it will go much, much faster than breaking it down and drawing all those different triangles. All right, part D says, what is the domain of the function? So now we're going to review domain. Remember, the domain is the set of all possible inputs. The set of all possible inputs. So what could I possibly input into this function? Well, I'm going to say could I input a 0 and get out negative 360? I'm going to say no, because what am I trying to input? I'm trying to input n, which is the number of sides. I can't have a polygon that has 0 sides. It wouldn't exist. Can't have a polygon with 1 side or 2 sides, and I talked about that in the lesson. So the smallest number of sides for a polygon is 3. So the smallest number I could plug in is 3. So I could plug in a 3. I could plug in a 4, a 5, a 6. Could I plug in a 6.5? Well, no, because you can't have half of a side of a polygon. So there is no data point between 6 and 7 because you can't have partial sides of a polygon. So I can plug in 3, 4, 5, 6, 7. So I'm going to say the domain is all whole numbers that are at least 3. meaning 3 or greater. And again, we just explained the reasoning. You can have 3 sides to make up a polygon. You can't have anything less. You could have anything more than 3 sides. You can't have partial sides, so that's why I said whole numbers, but that is my answer. The domain is all whole numbers that are at least 3. All right, and then part E, the last question here, it says use this function, the one we found up here, use the function to find the sum of the angle measures of a polygon with 10 sides. A polygon with 10 sides. So on this one, we're going to write down our equation, S equals 180n minus 360. And because it has 10 sides and n is the number of sides of the polygon, we're going to plug in 10 for n. All right, so we just need to calculate this and we'll get the interior angle sum. We don't have to draw a polygon with 10 sides and try to break it down into different triangles. So S equals 1,800 minus 360. So S is equal to, let's see, 1,440 degrees. And that is the interior angle sum of a 10-sided polygon. Now, I should also ask you, what is the name of a 10-sided polygon? Because you might see that pop up on your next quiz or on your assignment. So what is the what is the name of a 10-sided polygon? So if you're not sure about that, this would be the time to go back into your notes and look up the name. I included it on that chart. So this is where you're going to look if you come across a question like that. I've got it right here. A 10-sided polygon is called a decagon. So that is a question that you might get. I might say find the sum of the interior measures, find the sum of the angle measures of a polygon with 10 sides, and then I might include and name the polygon. So be prepared for that on your assignment and on your upcoming quiz. All right, so now you can get started on that assignment that I put it in the end of the notes here, the 5.3 practice worksheet that can be found on Google Classroom.